So now we've redone these experiments using our most modern gene expression tools, in this case called RNA sequencing. And we've got wonderful gene signatures for all the different immune cell types. And we can quantitatively assess how many of these immune cells are in a tumor. And it very nicely correlates with the pathology. So here's a tumor, high expression, many TILs. Here's a tumor, low expression, and few immune cells. So in this publication, one thing we showed was that the presence of these immune cells as assessed by gene expression is prognostic. But actually, when we look at it by subtype, it was only prognostic within the basal-like and the HER2-enriched subtype, and it was not prognostic within the ER-positive subtype. And actually, we can even go so far as to just look at the expression of individual variable region genes from different antibodies. And just the quantitative expression of the antibody variable region was prognostic amongst basal-like breast cancers. If we go back to that CALGB neoadjuvant study, these immune signatures also predicted an increased chance of achieving a PCR. So, and all of them did. So, the B cell signature, the T cell signature, the general immune cell signature all predicted an increased likelihood of achieving a PCR. Keeping in mind, none of these patients received immune therapy, right? So immune cells predict whether you're more or less likely to achieve a response to chemotherapy, which I think is important. Certainly it's important more important when we probably start talking about immune checkpoint inhibitors, which I will right here. Right? So one thing we looked at was whether these immune signatures correlate with the mRNA expression of these drug targets, and the answer is yes. Right? So when you have immune cells, it looks like you also have PD-1 expression or CTLA-4 expression, and so they're all highly correlated with each other. So I'm sure many of you are familiar with this. Actually, some of this was presented earlier, right? So some of the early studies of pembrolizumab in triple-negative patients were presented at San Antonio by Rita Nanda and colleagues. Of course, this is a very, very exciting area, very promising, right? Where, in essence, what we're doing is we're inhibiting the inhibitors of the immune response. So by doing this, we free up the immune cells to perform their function and attack the tumor. And so, when given to triple-negative patients as a single agent, I'm going to say this is a pretty good-looking waterfall plot, where a number of patients achieved a very good clinical response. A fair number of patients had stable disease, which, as I'm sure many in this audience appreciate, within triple-negative cancers, that's an achievement. But then, as with all these drugs, not everyone responds. Right? So there is going to be a need for biomarkers so that we can identify these patients and give them this very expensive regimen, right? And then potentially we should not be giving the regimen to patients who are not likely to respond. So in closing, in terms of triple-negative breast cancers, I think we should start thinking more about basal-like breast cancers, right? It's 70% of the triple negatives. If we're going to make therapeutic progress against triple negatives, we have to target the basal-like group, right? So we should think about the biology of the basals as we go forward. I didn't show you this data, but I listed this reference. Basal-like breast cancers are actually more genetically similar to ovarian cancers and to lung squamous cancers than they are to ER-positive breast cancer. I think an oncologist will go, oh, wow, well that explains the taxane benefit, some of the carboplatin benefit, right? Those are regimens that are being used in those tumor types for many years now. But now that we've done the genetic studies, I think we have an explanation for maybe why carboplatin has a role in basal-like cancers. I mentioned basals are chemotherapy sensitive, not all of them, of course, and here are some potential markers of that chemotherapy sensitivity. But clearly, we need a Herceptin for triple negatives, right? And maybe this is immune cell modulators, maybe it's kinase inhibitors or combinations of kinase inhibitors, or maybe it's some of these drugs which interfere with chromatin function and change the epigenome. We don't know yet. I know you know this is a very, very active area of investigation. And so I think something will come to fruition soon. So I'll close just by listing the many, many people involved in this project. Those in pink get special attention because they contributed significantly to what I presented today. And I'll just end by thanking you for your time and attention and for inviting me here today. Thank you.
Thank you very much, Charles. Большое спасибо. Дорогие коллеги, наверняка у вас возникли вопросы. Можно задавать. Можно? Профессор Петров.
Уважаемый коллега, я патолог, поэтому вопрос по сигнатурам, которые вы открыли. 2 года назад на Европейском конгрессе патологов известный патолог из Америки Дэвид Дабс сравнил сигнатуры, которые получаются при системе онкотайп с его иммуногистохимическими данными. То есть он исследовал те гены, которые в онкотайпе, с помощью абсолютно достоверных иммуногистохимических реакций. И показал полное несоответствие между его данными иммуногистохимии белков и активностью генов, которые в онкотайпе. Как бы вы это прокомментировали? Потому что после его доклада в Лиссабоне молчание было. Все были поражены. Как бы вы прокомментировали вот это несоответствие сигнатур с данными иммуногистохимии?
One thing I'll point out is they're not quite the same genes. Right? So the IHC is 4 or 5 markers, and oncotype is 16 markers, and my test is 50 markers. Right? So they are different, and there are discordances. I can't speak for oncotype, right? But I will say there was a publication I showed where IHC, oncotype, and Prosigna were all compared to each other on the exact same set of samples. And I would suggest that you and others go look at that paper, because I think that's the best comparison of those different markers on the same set of samples. And in that case, the gene expression test did better. And if you know the gene expression test, the immunohistochemistry didn't help. So that would be my answer. And that's typically what I've seen on our data sets. And I think the main reason is that having 50 markers is more accurate at measuring the biologic phenotypes than 4, right? Because there's redundancy among the 50. Right? So if any one of the 4 fails or has a bad IHC, that really hurts the test, right? If one of 50 fails, the test can tolerate that. So I don't think there's anything magical here. I think it's just there's power in numbers.
Да, это очень важно. Спасибо. Я сказал, что это очень важно. Спасибо.
Можно задать один вопрос как раз относительно соотношения иммуногистохимии и молекулярных сигнатур. Вот в молекулярном тесте PAM50 есть так называемый normal-like subtype. Насколько он имеет какие-то аналоги иммуногистохимические? Или нет? То есть какой иммуногистохимический аналог реально существует у normal-like подтипа при PAM50? Или никакого аналога нет, а normal-like подтип является техническим артефактом, когда при микродиссекции нормальная ткань преобладает в образце над опухолевой тканью.
So I think the answer is the last part of your comment. I think the normal-like group is indicative of that sample being overwhelmed by normal tissue and there being low presence of tumor. And actually in the new version or in the commercial version of Prosigna, there is no normal-like group. There's only 4 tumor subtypes. And the way to ensure that there is predominantly tumor tissue is that the pathologist is directed to take the tumor-rich portion of the tumor, and then that's what goes into the assay. So in many of the tests, all the gene expression tests, or many of the publications that we did over the years, were based on samples that didn't have as rigorous a pathology criteria as say is done in the clinical laboratory.
Спасибо. И еще один вопрос о соотношении молекулярных и иммуногистохимических тестов касается того, что вот в той итальянской работе, которую вы цитировали, по трижды негативному раку, насколько я понял, трижды негативный рак был определен иммуногистохимически на начальном этапе. И после этого вы применяли исследование молекулярной сигнатуры. И у вас было обнаружено, что среди этого трижды негативного рака, предварительно определенного иммуногистохимическим путем, какое-то количество больных молекулярными сигнатурами определялось как люминальный тип А. Вот как вы трактуете этот результат? Не может ли этот люминальный тип А, определенный просигной, реально быть молекулярным апокриновым раком, который очень близок по всем генам, кроме эстрогеновых рецепторов, к люминальному типу?